Hey guys, Mr. Betts here. I want to talk to you about the quotient rule, yet another shortcut in our toolbox of derivative shortcuts. This one's really similar to the product rule that we did in topic 2.8, but we're going to use it when we are dividing functions instead of multiplying functions. So the quotient rule looks like this. If we have a function that is one function divided by another function, then the derivative is given by this formula right here. Now, you may notice this one looks a little bit more complicated, but it does have some features that are pretty similar to the product rule. In particular, the numerator, if this were a plus, would be the product rule. There are reasons that it looks so similar to the product rule, and you'll see some similarities in the proof that I'm going to show you. But this is, again, another rule that you just need to memorize, and you need to know when to apply it. And with practice, I think that should come. So I want to show you why it works. This proof is really similar to the product rule proof, but it's a little bit more complicated. So I went ahead and did all the work ahead of time. So I set up the derivative of a of x as a limit using the limit definition right here. I started doing some algebraic manipulation. First plugged in, instead of a's, I put f over g. And then I got to this limit right here by clearing the complex fraction that we had here. And then I did that same trick where I subtracted and added the same term. And by subtracting and adding the same term in the numerator, I didn't change the value of it, but I was able to then get some expressions that were able to look like the definition of the derivative of f and g. And ultimately, we show then that the derivative of a is given by this expression, the quotient rule. So it might be kind of fun if you want to kind of go through and try that a little bit on your own. Certainly not something that I'm going to expect you to do on your own, but this proof right here using the limit definition of the derivative says now we can use that quotient rule for any derivatives that we know with functions that are the quotient of two other functions. So just like the product rule, the quotient rule might look different ways to us. So the top one is the one that I showed you at the beginning. We might see it in terms of u and v using substitution and different notations. The one that I like the best, this is actually how I memorized the quotient rule when I was in high school. It's a little rhyme, low d high minus high d low over the square of what's below. So if I look at this one right here, low is the bottom function, which is v. D high means the derivative of the top, so that's the derivative of u. Minus, so minus is important here. High is the top. D low is the derivative of the bottom. And then over the square of what's below, so the square of the bottom is v squared. So just a little bit of a rhyme to help you remember. It is important the order that we do this. Remember, with subtraction, we can't switch the order. 3 minus 7 is not the same thing as 7 minus 3. So we need to make sure that we are doing this in the correct order, and this rhyme might be helpful for that.